Welcome, everybody. Today is a very special day. We have the very special guest speaker, Dr. Bruce McCall from the States, present a paper on climate change at KREI. Dr. McCall is the winner of the Nobel Peace Prize in 2007 as a member of the International Panel of Climate Change. He is a university distinguished professor at Texas A&M system. Distinguished professor is the top 1% of teaching as well as researches at Texas A&M University. He is a fellow of the American Agricultural Economic Association, and he published many papers I knew. Still, I'm working with a paper with him. It is a long process. And he published in the top journal paper, such as Science. At Korea University, you published a science paper. University give the $50,000 for research money. Yeah, so you may try to publish the paper. Maybe you publish the Science and Nature. Maybe we give it a special bonus because he or she make our name to the world. Yeah. Dr. McCall is the mother of a professor I respect. He has 98 PhD graduates under his advice. And also, it is very impressive. He remembers all students' name. I have the many students. But I don't know how many students I graduate. I cannot remember all students' name. So he's very humble. He's very strict in class. Yeah. But he's very warm toward his students in class. I met him at Texas A&M in 1985, long times ago. He made an impact on my life. So it is my great honor to have him here. He wanted to talk with you, so that if you have any question during his presentation, you can feel free to ask him. Please make him feel welcome with a big applause.
Well, thank you for having me here, and I think I have 7 students that worked or either work here or used to work here. At least 4 of them are in the room, right? Although he's from Taiwan, so he doesn't count. I've been in Asia for a couple weeks, and I ended up giving a talk in Bangkok. I almost said Taipei. And this is out of that talk, and I changed the talk a little bit. This says I'm going to talk about adaptation, but I talk quite a bit about the climate change problem at first. So let's go ahead and take a look at this. When I start talking about the climate change problem, I frequently, it's one of those. It doesn't show up, right? That's okay. They don't show up on televisions. See, it works here, but it doesn't work on that thing. No, it doesn't work on that. It absorbs the TVs, you can't make it work. So, finger. So when we talk about climate change, we often think about slow-moving events. Maybe more typhoons, maybe more floods, maybe more droughts, hotter conditions, change in moisture. In reaction to that, we often talk about greenhouse gas control. That's net zero. You all have heard about the country's probably commitment to the Paris Agreement. That's on the mitigation side. Oops. But we can also talk about adaptation. If today it was threatening to rain, when you came to work, you might have brought an umbrella, or a lot of you are wearing coats to be warmer today. That's an adaptation to climate change. Mitigation, we limit the future climate change. On adaptation, we don't touch how much climate change, but we limit our vulnerability. And then finally, energy. Globally, about 80% of the emissions come from the energy sector. It's somewhere around 20% from agriculture. That's why an agricultural economist is talking to you about climate change, because agriculture is the second biggest contributor if you include forestry in it. So anyhow, I'm going to talk a little bit about all four of those things. Now, earlier this year, well, the last 3 years, our annual temperatures were a little lower than they had been in previous years. But this year, we're a El Nino year over the ocean, which is when the ocean is warmer. And I've been saying for 6 months that we're going to set an all-time heat record here. And so far we have. This is data up till the end of September, and we're now the hottest year we've seen since 1880. So we're number one for this year. In 2022, it was 46 years since we've been above the 20th century average. 2023 will undoubtedly make that 47. The temperature increase, if you take a long-term regression, has been a little bit under 1/10 of a degree centigrade per decade, but since the 1970s, or since 1980, it's been over twice that much. This January is the hottest ever. So climate change is accelerating. You can see it in that trend there that things are getting warmer. This is the El Nino explanation. I thought I'd drop this, but these blue is when we have La Nina, and that's the cold phase of the ocean. Notice these 2 years correspond to these two. The last time we were really hot is this one over here, which was a La Nina year. And next time you see this picture, it'll have this year as being hotter. This has led to cascading effects. Now, I don't know if Korea is very vulnerable to sea level rise. Bangkok certainly is. But this is what's happened to the ice in Antarctica, and this is what's happened to the ice in Greenland. Antarctica has been losing about 134 gigatons of ice per year. Greenland, about 287 gigatons. There are 7 meters of potential sea level rise in Greenland, and there's 53 in Antarctica. So if we melted all that, which we won't, if we melted all that, the water would come up 60 meters. For those of you who've been to College Station, Texas is about 70 meters. So we would soon have beachfront property where I live. This also is slowing down what we call the Gulf Stream, which warm water comes up off of Florida and it goes up and it goes to Greenland and then it comes down by Europe. This is going to slow that down and Europe will be a colder place than it's been up to now. The sea level rise, there's a couple different contributions to it. About half of it is due to, 42% due to melting ice sheets and glaciers, and about 50% from thermal expansion. If you take this thing of water and you heat it, it will break the top because the water is going to expand. And that's what's happening to the oceans. In Texas, this is the Gulf of Mexico. This is the Texas border. Down here is Mexico. Houston is right in here, or if anybody knows anything about Texas, the water has been getting much hotter. When the water gets hotter, that makes storms like hurricanes and typhoons stronger. So we've been seeing a greater incidence of these stronger storms. Here, you ever been to Galveston? Well, in areas in Galveston, the shoreline has been retreating by as much as 4 meters per year. So this year it's here, next year. And flooding has been more severe. You can tell I was in Thailand. Here, this is flooding incidents in May of 2023 in China. This is in just a couple weeks ago in Thailand. This is an area on the Canadian border of the US. The blues are floods. This goes from 1910 up to 2010, so 100 years. Notice the blues are more common. So we're seeing more incidents of flooding. As an economist, we frequently say that the probability distribution, we usually expect them to be stationary, meaning that you have the same probability of rains of different extents every year. It's clearly non-stationary at the moment. Somebody asked me about drought before. We're seeing more droughts than we used to, more severe droughts. Here, this one is kind of frightening to me. This is the count since 1980 up till now of the number of disasters in the US that cost $1 billion or more. This year we set an all-time record so far with 23. We still have opportunity for even more. Hawaii, that big fire in Hawaii, that's one of these. The big hurricane that went into Florida, that's one. Notice that 2023 had 23 of them. Previously, we had 22 of them in that year. This is the 9th consecutive year in which 10 or more events happened. Back here, we were seeing 3 to 6 events. Now, all of a sudden, we're seeing 20. So, why? That's just some data. The temperature's gotten warmer, we've had more storms, we've had more of these big disasters. Why are we seeing this? Well, I've been on the Intergovernmental Panel on Climate Change in various forms for 20-some years. And originally, just about, when did you finish your PhD? At 1990. So a few years after he left, we said that, well, we think humans are doing something. By 2001, when was your PhD? No, nobody here was 2001, right? You were like 2005, 2011? Well, anyhow, in 2001, we got to a 66% probability. In 2007, we got to a 90% probability. In 2014, when was your degree? About then? Okay, well, somewhere. I have had 98 of them, and I can't remember. And no, I don't remember all the names. But anyhow, we gave up on probabilities in 2014, and we said it's happening. And 2021, they said, no doubt. So humans are having an effect. There's something called the greenhouse effect. When the sun's rays come in and they hit this parking lot out here, some of them bounce off the parking lot and head back out into space. However, in a greenhouse, when you do that, you have glass up there. The sun's rays come through the greenhouse, they hit the surface, and they try to go out, but the glass reflects them back in. And we're seeing that happen because carbon dioxide, methane, nitrous oxide reflect bands of of heat back in. When Dr. Hahn was at Texas A&M, and I first started working on this. Atmospheric, we were about 340 parts per million. Today, we're right at 420. So the vast atmosphere that goes hundreds of kilometers up and covers the whole Earth's surface has had something like a 1/4 increase in the amount of carbon dioxide in the atmosphere while he's had his PhD. And actually, we see this pattern here, this sawtooth pattern. This is because right now in Korea, the leaves are starting to die and soon they'll fall off. In the spring, they'll regrow. So this is when the leaves fall off and the carbon's released back to the atmosphere, and this is when the new leaves grow. Over time, this is the temperature. This blue and green, wait a minute. The temperature is this red one, and this blue and green one is the atmospheric concentration. It's shown to be very highly correlated. But CO2 isn't all the story. We also have nitrous oxide and methane and a few other greenhouse gases. If we consider that, the current, in 2021, it wasn't close to 420 parts per million. Today, it's probably closer to 520 parts per million. The European Commission had a goal of stopping climate change, I think at 450 parts per million. They abandoned it because we're past that. I calculated the other day, anybody know what the low-end goal is of the Paris Agreement? It's 1.5 degrees. They say 1.5 to 2. You know where we are today? 1.4. So we're pretty soon to pass the Paris Agreement. I think I have that. It might be 1.3. I have those numbers. I think that you'll see in a minute. Although I think I updated them and didn't send you the final copy. In the last decade, we've gone up about 0.4 of a degree. So if we're 1.3 now, we'll be 1.7 by 10 years from now. Meaning the Paris Accord, it's going to be in the past too. Paris Agreement. And I don't know how many of you know this, but 1 ton of nitrous oxide, of which agriculture is 70% of the world's releases, traps as much heat as 300 plus tons of carbon dioxide. So that's why, even though we have the carbon dioxide here, we have another 50% due to these other gases. This is the one you can show somebody who wants to argue with you about this. This blue here is what would happen theoretically if I took a flashlight and shined it at this black object. Light is going to reflect off of that object in different wavelengths. So there will be some short wavelengths and some long. The reason the sky's blue in the morning is that's the longer wavelengths, and it's red at times, that's the shorter. This shows across different wavelengths of light, or the wavelength is here. This shows the amount being reflected out into space. This is a theoretical calculation done by a physicist. This is an observation done by a satellite. This particular part of this, where notice we're way below the theory, is the amount, this is where carbon dioxide operates. This is the heat trapped by carbon dioxide. So instead of all that stuff getting back out here, here's physical proof that it's being reflected back into the Earth's surface, and with that comes a lot of the heat. So that's kind of the why. We're releasing all these greenhouse gases. 80% or so of them, maybe 75, come from energy, about 20% from agriculture, the rest from some various other sources. This is the projection of what climate change is likely to do to us. These different colored lines are what they call a combination of social science pathways, is that the right SSP, and RCP, which is radiated force, representative concentration pathways. This one here is if we do not do much greenhouse gas control. This one is silly. It's if we stop greenhouse gases today. The relevant range is in here between this one, which is about 4.5 watts per square meter of trapped heat by 2100, and this one up here, which is 8.5 watts per square meter. The Paris Agreement is putting us right about here. So right at the moment, if we do very little, we get almost 5.5 degrees centigrade of warming. If we do the Paris Agreement, we get about 5. And then the more severe we act, the lower the future temperature is going to be. Notice up to date, we've had about 1 degree, actually about 1.4 from when we started back here in pre-industrial. And here we could get several times more as much. Now, I want to talk about agriculture a little bit. If we take a rice plant and we take the rice plant and we put it in a refrigerator, it's going to die. If we take the rice plant and put it in the furnace, it's going to die. In between is the ideal place where we're going to have production. So here in Taiwan, I don't know where I am anymore. Here in Korea, you know, for rice, you're somewhere up in here. Probably, for rice, you're somewhere over on this side. If it got a little warmer, you'd probably produce more rice. If you're in Bangkok, if it gets warmer, you're sitting over here somewhere. As it gets a little warmer, you're going to produce less rice. So this is kind of what we expect to happen. If I was estimating a production function or a relationship for rice production with climate variables in it, I need something like a quadratic term that can reflect the fact that in some areas I'm going to be on one side and in other areas I'm going to be on the other side. Canada benefits from climate change. The Canadian systems are over here. Thailand doesn't, and Texas doesn't, because their systems are limited by heat. So what this means is there's not uniform world effects of climate change. In some areas, we'll have beneficial effects. In other areas, we're going to have detrimental effects. Here, Jiyoung studies productivity. This one I find a little frightening. Here, this is a regression over 70 years data on corn yields. Notice over that data, on average, the yield increased by 2 units per year. This is 2 bushels, if people know that. Currently, the U.S. average yield is somewhere up in here, about 180 bushels per acre. When Dubong was in school, it was somewhere closer to 100. When I was in school, it was over here somewhere. But anyhow, we took that and broke it into sub-periods. When we do a regression from 1950 to 1973, this green part, it grew by 2.6 bushels of corn per year. The red part, which is from 75 to 2011, 1.8 bushels. The purple part, which is since 2013, less than 1 bushel. How are we going to feed the future if this kind of thing keeps happening? Like I say, that one's a little frightening to me. And we've studied this for a number of livestock and other commodities, for crop commodities. This is for livestock. Here I have cattle slaughter weight, the milk yield, the birth rate of young animals, and the survival rate of young animals. And the point is, notice every one of them has that behavior. And notice they all are right here about 20 degrees centigrade. If your average during the growing season is much above 20 degrees centigrade, you're on the diminishing productivity side. If you're below it, you're on the increasing productivity side. This is the same thing, but here we have hogs in here. So you can see hogs, they peak out somewhere a little bit below 20 degrees centigrade. The cattle, or milk is somewhere up right at 20, and the cattle are somewhere around 20 as well, and chickens are in here too. So almost all the animal production systems exhibit that same kind of behavior. Temperature is not the only part of the story. Carbon dioxide is also part of the story. For cotton, we found that about 40% of the rate of growth in yields is due to increased carbon dioxide in the atmosphere. For rice, in the paper Dr. Hahn was talking about, and I don't remember who else is on it. Are you on that? Maybe not. For rice, it's also about 40%. So basically, when the rice yields have increased from year to year by 10 units, 4 of those units are due to carbon dioxide, 6 are due to the marvelous research done by the agricultural research organizations around the world to increase rice yields. What this means, which is kind of fascinating, is in our study, we found the positive benefits from carbon dioxide were greater than the negative costs of temperature. So if we start going to net zero, your rice production may go down because there's less carbon dioxide in the air. Wheat's the same way. The big ones affected by this are cotton, wheat, and rice, a little bit for soybeans. Water availability is also an issue. I don't know, west of San Antonio, Texas, which is right out in here, we did a study on how much water went into an aquifer that recharged every year. Up until 1980 or so, that water going in was increasing. Since 1980, we see it decreasing. Up until 1980, notice the variability is relatively small. Over here, it's much bigger. So things are becoming non-stationary. We're having shifts in mean and shifts in the variance. And this shows what's going on in the U.S. as a whole. And there's areas where the rainfall is increasing, and there's areas where the rainfall is decreasing. Dr. Hahn was telling me that some of your soils, it would be hard to switch from rice to other crops, and that you'd probably have to have drainage. What this is saying is we're likely to have a bunch more drainage in the Midwest and the U.S. to keep up our productivity. This is depletion of aquifers. They have a satellite that can take an observation on the gravity in the Earth, and based on time series of that observation, whether or not groundwater is being depleted. In this particular case, notice the North China Plain, which is relatively near here, the groundwater is being greatly depleted. Well, hotter conditions means more water demand, so we're likely to have stresses coming from the groundwater supplies in many areas. This is the Texas High Plains where Ben did his thesis, and there we can see it's being stressed. So that's kind of the story. A lot of that is observed data. It's not really projections, it's what we've seen to date happening. Let's talk about how agriculture is reacting. Well, This is kind of a picture from Ji-Young Park's PhD thesis, but a little bit stylized. At the lowest temperatures, wheat performs the best. Then when it gets a little bit warmer, all of a sudden we stop wheat here and we switch over to corn and soybeans. When it gets even warmer than that, we switch over to cotton and sorghum, and even warmer than that would be a switch over to rice. So what happens in agriculture is these farmers are happily growing wheat, and then all of a sudden it starts getting hotter and hotter and hotter, and bingo, corn. And then it gets hotter and hotter, and bingo, out comes cotton. Canada today is producing 6 times as much soybeans as it did 20 years ago, and 2 to 3 times as much corn. Our commodities are going across the international border into these other countries. You said the other day you're seeing some shifts in commodities here. We did a study and documented them in China. I've never seen a study on it in Korea. We did do, and this is where we made a mistake, sorry, Ji-Young, and Sung Joe's not here, is he? We made a mistake in his thesis, too. We started studying how crops adjusted. This is where corn was in the United States in 1975. Look at where these little green dots are. There were a bunch along the eastern seacoast, and there were a bunch up here. Notice this is the border between the Dakotas and Minnesota, and this is Nebraska, and there's not so much there. But when we get to 2020, now all of a sudden there's a whole bunch of corn out there in Nebraska, and there's some corn slipping up here in the Dakotas. We'd also see corn going into Canada if we had Canadian data as well. So this is a shift. We documented, on average, corn moved north and west about 170 miles. And notice there's none left down here. Here's the mistake we made. We considered replacing this with other crops, but we forgot about hay. If you look in the United States, you see a lot of these big round bales of hay. Farmers have moved the hay down into here and increased it. They put hay, there wasn't any hay back in 1975, but now all of a sudden there's a bunch of hay in these areas. So the grass is coming in, livestock grazing and production of grass for livestock. Also, for the person who studies wheat, here's what's happened to the wheat. In 1975, we had the wheat in the Dakotas pretty strongly. Notice now we've basically moved the wheat out of South Dakota, and the wheat is moving up. And if I had a Canada picture, we'd see it predominantly moving into Canada. Sung Ju did this too, although I used an older reference. This is the allocation of land between pasture, livestock grazing, and cropland. And notice after, let's see, this is 60, so 20 would be somewhere around here. Much after 20, you're switching out of cropland and switching into pasture land. So we're seeing a shift here in where that land gets used. And this data here, I won't talk about it very much, shows the number of animals per unit of land is reduced by about 1/3 as it gets warmer. So not only do you have land moving over, but on your pasture land, you've got about 1/3 less animals for a unit of land. Here, I don't know what kind of cattle breeds you use here in Korea. That's what I am. There are 2 fundamental cattle breeds in the world. There's Angus cattle, which is a British breed, I think called Bos Indicus maybe. And then there's a Brahman, which comes from India. The Angus cattle are dark colored, black. the Brahman cattle are white colored and they have a big hump on their back. Anybody have a black car here? And go and get in your car after a really hot summer day? And anybody have a white car or have a friend with a white car? You're crazy in Texas if you own a black car, because I used to have a midnight blue car, and I'd get in the car and I couldn't touch the steering wheel. It was so hot because that black color absorbed all that heat. I don't own anything now but white cars. Everyone is white. And they don't get anywhere near as hot. Well, here these white animals are much more prevalent in the hot areas of Texas than these dark colored animals. So this is a climate change adaptation. These are things farmers are doing in their own best interests. I could mention lots of other effects. I won't go into that. This has a list of them, or well, that has a bunch of them. I do want to talk about an economic force here, and then I'll go into another topic, which is the U.S. government has an estimate of something it calls the social cost of carbon. That is the cost of putting 1 ton of carbon dioxide into the atmosphere. This is at a 2% discount rate when it's put in now. Here, when it's put in 80 or 60 years from now, here the cost is $200 per ton. Here the cost is $400 per ton. Currently, if I burn a ton of coal, for every ton of coal I burn, I get 2.5 tons of carbon dioxide. $500 worth of damage if we internalize the externality from burning that coal. And in the U.S., the coal costs maybe $50 a ton. So the damages are 5 times as much. If we price that into the energy, then we internalize that externality, it's really going to cause fuel switching and net zero and all that. So this is kind of interesting data that they've developed recently. This is based on a set of CGE type models that have agricultural productivity, human health, property damages from floods, sea level rise, lots of different factors in it. So now let's turn to what is projected. Well, anybody know when you put carbon dioxide into the air, how long it's going to be there? %40 for 1,000 years. And another 25% for 10,000 years. So when we put it up there, it isn't going to go away real fast. Methane has about a 20-year life. So rice from methane comes and goes pretty fast. But a lot of this stuff is going to be there for a long, long time. And that creates what we call in the business of climate change commitment. Notice here, by about 2040, how much we control carbon dioxide doesn't matter. We get about the same amount of warming under all these different greenhouse gas controls. And it's about taking us to 2 degrees, whereas right now we're somewhere close to 1 degree, meaning we're going to have as much warming in the next 20 years as we've had in the last 140 years. That, to me, is a real call for agricultural research, because the question is, how can we produce food under this 1 degree set of warmer conditions equivalent to how we're doing it today? I don't think agriculture is going to be a huge player in net zero, but I do think agriculture's got to be able to accommodate hotter conditions. Here's projections on rainfall. I did pull out these Asian diagrams, but I think this one says Korea is going to have hotter evaporation minus precipitation, or more water. Here we have more water in the Korean area. The reason somebody from Texas is talking to you is that this is soil moisture and there's Texas. Texas is heading for a disaster in terms of agricultural production. Korea, probably not so much. Korea may have problems with this, where it's a lot wetter, and how do you manage all that water? Sea level, this was Bangkok, so I didn't remake a custom set of Korean slides. My sister, she lives right here, which is right here. So my sister, if she stays in Florida and lasts till 2100, is going to have not oceanfront property, ocean bottom property underneath the water. She actually already learned this because she bought a place here in the Florida Keys a couple years ago, and the hurricane destroyed it. She bought it in June, and it was gone by September. No insurance, because they don't insure it well. I've been telling her for 20 years, get out of Florida. She doesn't listen. She's all ready for graduate study, since she doesn't listen. Anyhow, the other thing we expect is carbon dioxide to make the ocean more acidic. When carbon dioxide is absorbed into the ocean, the pH of the ocean changes, and it makes it harder for corals, for mollusks, or that's clams and oysters, and crustaceans, that's shrimp and lobster and crabs. Notice in all of these cases, there's real damages being done as that pH and as the carbon dioxide gets higher. So if you like your seafood here in Korea, start eating it fast because it's likely to get in worse shape over time. So here's our decision space. Basically, there's three different things that we can do. One thing we can do is what the U.S.'s strategy was in the Kyoto Protocol. The U.S. said, we're not certain enough about what climate change is going to do. We're not going to do anything. We're going to sit and wait to see what happens. And we're collecting information, but we're taking the impacts of climate change without a big preventative thing. We can adapt. Farmers do adapt. When it gets warmer, you don't have to tell a farmer, your rice isn't doing something very good, maybe you ought to do something else. Or that black cow, they're having real problems because it's so heat, go find a white one. The farmers are going to do that. But the issue is, how much of that will farmers do? Autonomous means the farmers do it on their own, in their own best interest. Who will adapt? What incentives do we need? The Paris Agreement has a $100 billion climate fund. There's some Jew. Has a $100 billion climate fund in order to compensate people for adaptation and mitigation action. Of course, nobody's given them that much money, so it's $100 billion on paper, but probably quite a bit less in practice. And are there imperfections in adaptation, and how effective are different actions? On the mitigation side, this is greenhouse gas control. When somebody says to you, I want to mitigate climate change, don't think they're talking about making hotter conditions less damaging to them. They're really talking greenhouse gas control. So there, as economists, we want to know how much should we do? What strategy should we use? How much does it cost? How effective are they? What incentives? Are there imperfections? When I started doing climate change, the first thing the EPA asked me is, how damaging is it? Because they wanted to know, is this $10 a year or $10 billion a year? because that tells them how much of this they should do. Today, we're fairly well convinced that we ought to do mitigation, and there's certainly a global consensus around action. So here's the decision space. We're not going to do any one of these. We're going to do all three. Right now, here in Korea, you're probably suffering some effects of climate change. You're doing some things to reduce greenhouse gases, and crop mixes are moving. So somewhere out there in the middle is where we're going to operate. Here are the different actions we can do. We can observe, we can plan to adapt, we can pass some kind of a price signal for greenhouse gases, we can reduce our carbon footprint. This is the net zero activities. And we can reduce adaptation barriers. We can help develop new ways farmers can adapt and provide financing and things like that. On the adaptation side, there's a definite climate change commitment. Bunch of you live in these big, tall apartment buildings around here, I'm sure. Do you think we're going to knock them down and insulate them better so they release less emissions? Anybody going to drive their car off a cliff and go buy a new electric one next week? I mean, there's what we call asset fixity, where it takes a while for capital stock to turn over, and that's part of a climate change commitment. It also supposedly takes about 400 years for the ocean to come into equilibrium. So given the heat we've already given the ocean, it's going to be a long time before we absolutely stabilize. Here's that picture I was showing you before, where notice there's a fairly narrow band of future temperature we expect in the next 20 to 25 years. And it's pretty inevitable we're going to get about 1 degree more. This is why I think everybody is working on net zero and mitigation. I'm working on adaptation because I think that's where agriculture is going. Also, I think the agricultural role in mitigation will be somewhat small because we still want to eat. So we're not going to stop fertilization of crops in order to get rid of greenhouse gases. We're still going to have food. On adaptation, there's a bunch of different things we can do. You can make heat-tolerant infrastructure, improve your apartment buildings. We can get solar put in place, more efficient, batteries. There's some variability. There's some information dissemination. Farmers in the U.S. that have always grown wheat don't know how to grow corn. We have to get them the information on how to do that. And then there's some infrastructure investments. We may need to build new dams and facilities to hold water back, and also some water conservation activities in Texas. Here, maybe not so much water conservation. There's kind of an interesting economic spin on adaptation. One thing that I was told just the other day is there's a very popular squid. You know what a squid is? There's a very popular squid that grows in Mexico. And so whenever we wanted to eat that squid, we'd go catch it in Mexico. Guess where they're catching it now? Anchorage, Alaska. That's almost 2,000 miles north. Same species, it migrated for colder water. There's still some in Baja, Mexico, but the thing is, the birds and the fish and the animals, they don't have to be told it's getting hotter and they don't like it. They go and go somewhere else. I've heard that Chinese fishing fleets and Japanese fishing fleets, no longer do they go to their traditional areas, they have to go further north. And so there's natural adaptations. There's also what we call autonomous adaptations. I don't have to tell you if it's going to be 10 degrees colder tomorrow to bring a coat. you're going to do it in your own best interest. This is what we call a private good in economics. But a number of private goods are not going to happen, and this is where we come in with public good provision. Namely, if, I don't know what's close, if in New Orleans, Louisiana, we need to protect ourselves against future strong hurricanes, no one individual is going to be able to do that. The government is going to have to do that. If farmers need a new rice variety that does better under hotter conditions, the farmer isn't going to do that. It's the research and development enterprise around the world that's going to do that. So there's three forms of adaptations. The natural ones, the ones that people are going to do on their own. We don't have to pay them to do it. They're going to do it entirely on their own. And then there's ones that the federal governments are going to have to be involved with. The federal sector may need to help provide information and new varieties to support autonomous, and then they may need to build dams and change infrastructure, and they may also need to influence natural adaptation by managing things we didn't traditionally adapt. One of the things we worry about in the United States is polar bears. And the polar bears are having trouble because the ice is receding and it's away from their traditional fishing grounds. I still have this image of, in the U.S., sometimes people buy 6 oil drums and put planks on them and have a little float in the middle of their lake. So I see us putting floats out for polar bears to swim to and do things we never even thought about doing in the past. I ran into a woman who loved conservation of butterflies. She captured a few, put them in the car, and drove them 100 miles that way and let them loose. It's things we've never done before, but we may have to do them. There is something, do you know what a treadmill is? You have a bunch of them, I think, in that room downstairs. That's where it's going around and around, and no matter how fast you walk, you're not going to gain on it. Adaptation, you're not going to be able to do it once and say, oh, I'm done. I don't have to do any more. You have to continue it. It's going to be a continual process. There are some adaptations that work well and permanently. I told my sister to get out of Florida. She won't do it. I own a house in Colorado at 3,000 meters. Sea level rise isn't going to get me under any circumstances. So that one's permanent, but say with changing crop acres, you're going to have to change that management rather continuously. Traditionally in agriculture, we did research on something in an area and we said, oh, we're done. Gee, we got a new system. We're going to have to keep doing that. Because no longer is the weather stationary, it's now shifting over time. So the grand challenge here, we're not going to be able to find a policy approach that works. We're going to have to use multiple ones. We're going to face demands for adaptation, information on climate change effects, and mitigation, as well as how to reduce variability. We're going to have to efficiently use money. If you in Korea spend a lot of money on climate change adaptation and mitigation, your budget's going to go down because they're taking money that traditionally went to this budget and putting it over somewhere else. So how we balance this, there's many tricky issues. And we're going to need to strike a balance between the climate issues and the traditional non-climate investments. So you're going to live through this. I turned 75 2 weeks ago. I'm not going to see all this. You are, a bunch of you. And so as a consequence, you're going to have to decide what you support. You're going to have to decide whether you tell the company here or the government how to react, what to do in adaptation, what to do in mitigation. And you may also have to document Jiyoung tells me she's working on factor productivity. She may need to do some work on how factor productivity will be affected by the climate. So we can anticipate what kind of training we need to do, what kind of research and development, et cetera. So that's it. I made 55 minutes, or 50 minutes. So. It's okay. You were an A&M student, but he didn't take my class, so I don't know who he is.
Yes, I graduated in 2014.
And you lived on the other side of the hall from me, so I never went and saw
Yes,
you.
right. You tell us about the agriculture sector contribute almost 20% on carbon emission.
Right.
And you also show us that the sharp increase in carbon emission recently. And as far as I know, the primary crop production in the world has been increased 50% in the last 2 decades. So probably agriculture has a significant effect on this recent the carbon emission increase. But you talk about a lot of the adaptation things, and you worry about how we can maintain agriculture production level, current level. But if agriculture sector is significantly contribute to carbon emission, and if it's more, I mean, it's a huge recently, but is it necessary for us to think about how we can reduce our agriculture production while we keep food safety level?
Well, the big trend in the profession, and it was started by a couple economists at FAO, is for what we call climate smart agricultural practices. And these climate smart agricultural practices are designed not only as mitigation, not only as adaptation, but as a combination. It turns out that, say, in rice, if you add more organic matter to the soil, that will hold more water and reduce your need to pump water potentially. It will hold more carbon, so it's going to increase the amount of carbon sequestered from the air. So that's a case where an action you can undertake has both mitigation and adaptation effects. Now, we need to find those and exploit them where we can. I think in a lot of cases, if we need the food supply, we're just not going to be able to reduce production. Here, I don't know what your population situation is like in Korea. I know you have a low birth rate, but are the total number of people, but is it going up or down? So you may not need a lot more food production, but in Africa, in South America, and in this underdeveloped place called Texas, we have substantial population expansions. Texas is at about 35 million people right now. It's supposed to be 50 million people in about 10 years. We have a large Hispanic population that has high birth rates, and with those high birth rates, we expect expansion, but that's not true throughout the U.S. So in cases, in the U.S., we do expect the population to keep growing, so we are going to need more food. In other areas, you may not need so much more food. And I think there's a trade-off between greenhouse gas control and food production in a number of cases. And so we're going to need to manage that carefully so we have sufficient food. Right at the moment, in a lot of, well, I mean, you see the stories out of Ethiopia, and you see the stories out of areas in like this Hamas situation. I mean, there's a lot of starvation in the world, and I don't know that we can really say we're going to convert world agriculture to greenhouse gas control and not worry so much about some elements of the population. questions? I do have, if anybody wants it, there are two other presentations I made. One is a 2-hour one where it talks about all the things my students did, including you and you. And,
To God, please give me the right eyes to see the future. So we have to design the environmental policy to fight the climate change after 100 years. So as a policymaker, we make a portfolio, investment portfolio between the short run and the long term. But it's after 50, after, definitely I died after a certain a couple of the years. Yeah, but how can we design the policy so we have to, for politicians always short eyes and they do not concern about long-term investment, long-term portfolio investment, such as finance always discuss about the portfolio between the short-term period, but it's a climate change. We have to allocate the budget over the 100 years. So what is a good advice to the policymaker in agriculture and the environment? So that is my big question these days.
well, you're the one who deals with the policymakers. I'm just an academic professor that sits in the back room. What I think is important is how many of you knew what was going on with the billion-dollar disasters in the U.S.? I mean, probably none of you. You never had seen that data. And we really have to show people what's happening and show them some of the causality. And the IPCC has been great. When we first started in the IPCC and I first started in climate change, everything was based on models, and we were projecting what would happen under this event or that event. Today, the IPCC is using data, historical data and econometric analysis to tell what's going on, and then they're informing policymakers. And at this stage, excluding little backward countries like the United States, a lot of the policymakers are really engaged in this net zero activity. And so I think we've done a good job of convincing people to do that. Now, how we get local monies allocated in order to have some of that happen, that's for the politician types like presidents of research organizations and things like that. But we really do need a system of incentives, and we really do need that information out there to document what is going on. And then some policymakers are going to be forward-looking enough to do that. In the United States, right at the moment, we can't even elect a Speaker of the House after, I think they're up to 5 candidates so far. And the government's going to shut down in 2 weeks. I just had a trip to Washington canceled because they said that we're not going to be there by the time you come here. So how you get past some of this real short-sighted, I don't know. I have testified before Congress in the U.S. Every politician that we talked to believed the climate was changing, but all in one party did not believe humans had anything to do with it. But that's really changing now. I mean, we're beginning to see people interested in pursuing longer-term policies. By the way, on this research and development, the corn yields I showed you, the one thing I didn't talk about is our level of investment in research and development is going down. And that's true globally. I don't know what's true in Korea, but we have arguments that you should get more money rather than less based on our research productivity studies. And we really have to show not how productive labor and capital are, but also how much climate is altering that and whether or not it's bringing us to an unsatisfactory situation.
Like myself, my institution is very similar to KREI, and we are very interested about in this climate change
trend or policy or net zero policies. In your views, what is the latest research you recently discovered in recent maybe 3 years or 2 years compared to maybe when I was a PhD student? The
Back in
research
the-
you have done.
In the olden days.
Yeah. What is the trend? Any new trend for the research?
Well, the biggest things that I'm interested in now is the two Koreans sitting there in a row. When we were looking at changes in crop mix, we ignored some of this other hay and some of the changes in grass. You did two essays. One had the grass part, the other one didn't. Just understanding how these crops are moving and how it may force us more into grass and change our calorie production across the country, that's important. Also, seeing the importance, I mean, some of your South Korean production possibilities are going to move into North Korea. And what you guys do about that politically is going to be an interesting question that you have to answer. In the U.S., we're seeing things move into Canada. So understanding that is something we've been working on and what the adaptation possibilities are. The other one that I'm starting to work on and think about is when I was doing this work 20 years ago, wind and solar were too expensive, and I wasn't really considering those. But nowadays, wind and solar are just coming on big, and moving from gasoline-fired vehicles to EVs moves from a non-point source of pollution to a point source of pollution, and something we can capture the carbon and really do something about. So we're beginning to think about those kinds of things. The other thing, the last thing I'll mention is we call it carbon capture and storage. That's when you take a power plant and you grab the carbon dioxide and you may put it underground. But what's becoming big in the US now is carbon capture utilization and storage. It turns out that you can take that captured carbon and make a degradable plastic out of it. So you can take the carbon, and we have a process that I'm working with, I'm doing the economics and the greenhouse gas accounting on, where you bring carbon dioxide in and you hit it with electricity, and you make acetate and something else out of it. And then you can take that acetate and migrate it into a plastic. And the plastic, unlike this thing over here, if it has organic material in it, when the sun hits it, it decomposes. So it begins to solve some of the plastics problems we have in the oceans and in the land. So that's another thing we're playing with, is ways that you can do these kinds of things. That's not an agricultural thing, but ways you can do these things to solve pollution problems and climate change problems.
Thank you. I believe all of us today learned a lot from Professor McCall's presentation, and we all got big intuition for our next research. So it is my great pleasure to introduce our next speaker, Huan-Yi Lin from Tsinghua Institution for Economic Research, CIER, in Taiwan. He has begun his career in CIER since 2010 after receiving his agriculture economics PhD degree from Texas A&M University. Currently, he's the director of the Center for the Science and Technology Policy Evaluation and also director of the Center of Japan. His CSTPE team has continuously worked with Central Weather Administration in Taiwan for evaluating the economic benefits of weather information applications on various sectors, investigating the needs of users and providing policy suggestions. So his current research interests include natural resource and environmental economics and climate change economics. Please let's give him a warm round of applause.
Thank you all very much for this afternoon to have me to join these seminars. I'm Hannah Lin from Tsinghua Institution for Economic Research. I believe I'm the number 57 PhD graduate from Dr. Macau's students. Right now he has 98, right? So I'm 57, and I think Song Woo King, who was my former classmate, he is 61, number 61, remember? And I think I'm here to share about my story. I think like Dr. Han said, Dr. Macau, when we were a PhD student, he is for the study. He is a very strict person, and but after I returned from the U.S., I feel like he has gave me a lot. So that's why I start my career at my institutions. And for this presentation, I will give you my stories about how I developed my career at CIER. Very similar to Dr. Han said, when I entered the institution, I figured out the thing I learned from my PhD thesis is not enough. And I have in my institution like yours, we have many tasks from the government or from the government agencies. We have a bunch of problems to solve, so I need to figure out how to solve it. I thought I was a model builder when I graduate, but when I enter CIERs, I think I have conduct many field surveys in farms, in agricultural farms, even go interview with fishermen in to different sector stakeholders. It's totally completely different from I thought when I graduate. But finally, I formed my teams, and we have very long-term project supporting my team to continue our work. So let me introduce my institution is actually right now is still on the campus of National Taiwan University. It's a government-funded institutions. Right now we have more than around 400 staff, including research fellows and administrative staff, and also project-based research associates. We have around 400 people in this building to work for the CIER, and we are founded since the 1980s. We had many divisions and centers, and right now I'm the director of Japan Center and also the Science and Technology Policy Evaluation Centers. And this is the photo taken in the last week. we I have two teams together because we have a lecture last Friday. We invite a professor from University of Tokyo, so we finally have a chance to have picture all together with CSTP teams and the Japan Center teams around. I think more than including our colleagues at Tokyo office, we have around 30 colleagues altogether working with me. And this is our Japan Center. So we have our office in Tokyo. So if anytime you have a chance to visit Tokyo, my colleagues or myself, if I'm in Tokyo, is very welcome to visit our office. And before I start to talk about my career in the last 12 years, I would like to share my thought to, especially for young colleagues at KREI. After so many years training, and also I think I'm very thankful to Dr. Macron for his effort to, let me have everything trained. Then I come back to Taiwan, and I take my first project from this is my first PI project from 2012. I came back in 2010, and 2012 is my first project. I was in charge of strategic planning for Central Weather Administration. And then they asked me as an economist, how can you do the policy evaluation for me? Because I provide the public service to all the citizens, but the Congress or the budget committee want me to evaluate what can you do and what is the social benefit if I give you such a budget. So they need economics to join their project and evaluate their performance, even evaluate the potential benefit if they have the special fundings from the central government. What would it be like, such as the potential benefit or economic benefit? So as you see, I work for CWA for more than 11 years. And we start from agricultural sector. So during those years, I only have one research associate and one assistant with me. We have three person teams together from here to here. And we by that time we go to field surveys. No. In my institution, we only probably have 2 or 3 agricultural economists, but most of us live in Taipei. They never go to the rural areas. And I was young. I said, okay, let me go to field studies, and because also I speak local language, so I can communicate with the farmers or the stakeholder very easily. So I start my career from agriculture, but I didn't learn it from Texas A&M. I thought I was a model builder, not field survey expert. But due to my work, I need to do that, so I made my best effort. Only me, my research associate, and the assistant, 3 people go to the field surveys. So I do a several survey for agriculture, fishery. We go to visit fishermen or agricultural farmers, and we also have a survey for livestock farmers. Okay, so from time to time, you can see gradually we start to make a research in agriculture, fishery, and livestock sectors. And in 2016, we finished even for disaster reductions sectors. And then we, in 2017, CWA, they thought, okay, they think maybe my work is very helpful to them. So they give me another task. I start to research on energy sector, how they use weather service or weather information. And the health sector, I interviewed the many doctors or the public health agencies in different counties, different cities, different township. And I got their feedback, and I make a report to CWA people, tell them what is their feedback, how shall you improve your service, what is the potential benefit you can create for the stakeholder in this sector. So in 2017, I have agriculture, energy, public health. This is actually, those are not the area I learned in the past, but I need to face the challenge and take it. Yeah. And 2018, CWA people, because of those work, they have received a very big funding from the central government. So 2018, that time, by that year, suddenly I have maybe more than 5 times of the funding from CWA. So we have a very detailed and a very general service for the household in agriculture in Taiwan. And also, as you see, 2018, I continue my research to forestry, tourism, transportation. Okay, so this, when you see this chart, this is the year, this is the area I touch, and the 2020. So you see, we developed so many research areas from traditional agriculture to energy, health, forestry, tourism, transportation, water resource, finance. And this is a household sector, other industry, and the weather industry. So this is what I have been doing in the past. And as you see this year, I also still do agriculture, but we have transportation here, and water resource, finance, public sector, other industry, and weather industry. And this is just maybe 70%, 80% or 70% of the workload for CSTPE. So, but how do you do that? I think from here, because I have enough funding, so I keep looking for partners. I invite several of my CIA colleagues to join my team. As you see in the previous pictures, they are all PhD graduates, some from Penn State, some from Taiwan National Universities. I invite them to join my team, and we work together. That's why we can, do so many research in different areas. But this is the research project from Central Weather Administration, like KMA in Korea. Okay. So this is what we have been done in the past. Okay, so agriculture, as you see in the previous slide, we have done this for, I think, around 10 years. And we continue to update our numbers or our feedback from through conducting surveys, and we have discover different trends, like the farmers in 2018 and the farmers in 2022, their response is a little bit different. They use smartphone more often compared to 2018. They said their willingness to pay is lower, but we suggest CWA that is probably a good thing. Right now, the farmers do not rely on CWA only. They probably use different resources to access or to know the weather forecast or information. That's why their willing to pay is getting lower. In the past, they think you are the only sources to access weather prediction. And after that, the number is going down, but this is for fishermen, this is for agricultural farmers, this is for traditional agricultural crop farmers. But this is only take average, but you see their average willing to pay is different. However, the number is totally different. This group is about more than 500,000 people here. This is only maybe 20,000. This is also 20,000. The number of the people in that group is totally different. So we keep continuing doing the survey for CWA and give them the feedback, and they will know if they want to make weather information for the viewers or the stakeholder in these sectors. After our analysis, they know how to improve their service for agriculture. And this is another interesting studies. One maybe I forgot which year, but in 2018 or 19, we have a case study in Alisan Forest Recreation area. We asked the visitors who come to this area what they want most, if they can have a very special customized weather forecast index. And we figure out if you or the industry, the private sector, want to provide a special service for those visitors, the most thing they want is the stargazing index, because people go there, maybe most of them are from the cities. They want to have star viewing at night. So they want to know today, is it good for stargazing? Or is it a clear sky when I visit the forest recreation area? So this is one of the important starting point when CWA people go to visit the Bureau of Forestry, because this recreation area is is under the governance of administration of forestry. So when CWA people go to see the administration of forestry, they will talk about how about we have this service for the visitors. So this is another thing we have been done many case studies or very different studies. So in the last maybe 3 or 4 years, we continue to publish several papers. They are in English journals or in Taiwanese journals. More than 10 papers have been published. So we used to, this is QP sum is a system give to the road administrations to let them know if the weather is extremely dangerous, what kind of timing they should close their road. Okay, so we trying to help CWA people to estimate. Okay, after you provide this QP sum system, what is the potential benefit you create for the society, or due to your measures, what is the possible monetary value you create? This is for cycling is a very special one in transportation, because by that year the MOTC, Ministry of Transportation and Communication, they are promoting cycling. So we do a survey of cycling about whether information can do for cycling or the activity or the sports. And this is for tourism. We asked what kind of weather information can do for hotel management and as their economic valuation. And this is another special case study we are going to publish maybe this year or next year. We do a choice experience model to test the visitor to our island, Honghu Island. Yeah, we have some special case studies, and we expect maybe in the future we will publish those results to a journal article. Okay. And this is what we have been done for this year. It is the 4th year. We help CWA people to evaluate the general household. So we really conduct phone surveys for the Taiwanese household. And from 2020 to 2021, 22, we continues to do the surveys, and we have continued to analyze those respondents. What kind of character, which kind of people, which group of people need weather information mode, why they want to use this, which kind of weather information, and how to improve their usage of weather information. Okay, so the last one is the recent 3 years during the pandemic. We have another mission, assigned by CWA. So this is, the think tank always do, very different from academia. Sometimes we have policies, and then the agency say, hey, we want to do this. Can you help us? So this is in 2020, the minister of MOTC, he wants to promote weather industry in Taiwan. So he asked CWA people trying to figure out how to do this. So my team also joined the test group for promoting weather industry for CWA. Not just do how to promote it, the policy thinking. We actually do a series of research for CWA in order to initiate this policy. This is maybe just for your reference. I think my time is not enough. So we have figured out, we go to interview the supply side and the demand side of the industry. We figure out several problems. So we have this problem. We point out those problems, and we tell CWA people, we have those challenges and how we can do it. So we propose that CWA people should focus on the infrastructure and the model simulations, and then they need to think about the weather industry as part of the natural industry, and maybe the best way they can do is trying to invite several non-profit organizations to build up a non-profit platform to promote the industry. So this is according to our previous surveys. This is totally different from my field survey. This is in the weather service market. We interview the company, the small medium enterprise or big company. We're trying to figure out weather information or climate data can do for them for company management. So we have figured out several sectors who need weather information most, like agriculture, disaster reduction, energy, health, and water, and also transportation, tourism, and constructions. And also in medium level is beverage and textile industries, and low level is electronics industry. And here we figure out one problem because in Taiwan most of the enterprise are SME, small and medium enterprise, but they do not know how to do it. Yeah. So we figure this problem out. Let CWA people know maybe in the future SME can play a part. Let's think about how we can do for them. So this is the survey. As you see, 1/4 of the people say, okay, I use weather data for my business. 38% of people say, I know there is some impact, but I don't know how to do that. Okay, or I do not use that. And another 38%, they said it's not my business. I don't think that there is an impact on my business from climate or weather information. So this is also from our surveys to the public companies. So we figure out maybe the top 3 is construction sectors, and here is arts and entertainment and recreation, because if you want to hold a very big event or big performance, big show, and they need to know the weather information in advance. Okay, and another is finance and insurance, because they want to know the weather data and the climate data if they want to issue insurance to their customers. Okay, so this is for your reference. So during the pandemic, I'm not flying out very frequently, of course. So I stay in my country and help CWA to build the TCSP. This is a non-profit organization to help CWA and the private sector. Is a platform to promote the weather industry. So in the past, in the last 3 years, I'm working on, building these non-profit organizations and trying to use this platform to have a better communication from the government side and to the private side. And right now, we are also help CWA to think about how they can build weather data, big data centers, either inside the CWA or they authorize another institution or TCSP to do those for the private sector here. Because by doing so, this is the only way they can do, because there are more needs from the private sector or from the society. And the CWA, the government agency, they cannot do it alone. They need to build a private and public partnership. And a lot of things, the private sector, if there is a business opportunity, I think they will join in. And CWA people, they provide the data to them. And they will make the business work. So this is my today's presentation. I have a lot to want to share with you, but hopefully maybe in the future, I can talk one specific topic maybe for 30 minutes. Yeah, today's 30 minutes is not enough, I think. So this is my brief presentation for you. Thank you for your listening.
So due to the time constraint, let me just get one question for Dr. Lin, if you have any question for.
Thank you for your presentation, Dr. Lin. I am curious about you have assessed the economic value of weather information. So I also have experienced the research, but in my case, I researched on only farmers. But in your case, by stakeholders, coastal fishermen, and aquaculture and agriculture. So the difference is a little bit big between stakeholders. So I am curious about that. There are many kinds of weather services. For example, short-term information, long-term information, and typhoon, and temperature, and precipitation, and so on. So what kinds of weather information did you ask of them?
Yeah, we are really an expert. Before we conduct our surveys, usually we will have focus group to interview, or we need to do some consultation meetings with the expert in fishery or in agriculture. So, for example, for fisheries, they don't care about temperatures; they care about the winds. They care about the waves, the ocean, the marine environment, because they are going out on the sea. So they want to know if they go on the seas, are they safe to work in that areas, or what would they expect that they can stay to catching the fish in that zone for how many hours. So those are very different information from the weather information for traditional agricultural crop farmers. Yeah, but for aquaculture farmers is also very similar to crop farmers, but they raise their fish in a pond. So it's totally different, different idea that, for instance, they want to know if there is a cold front from the north, how strong the wind is, because not only the temperature going down, they want to know the winds, because in their pond they want to know the temperature change in the next several hours. Do they need to do the prevention measures, to prevent their ponds, the temperature going down very fast? So they need to make a heat to the pond and keep the pond, the temperature in the pond in some friendly temperature range. So is every time is my challenge. When I take different areas, I need to do my own research. I also need to go to interview the expert in that area from the academia or from government agencies. I will go to visit them and interview with them and ask them their ideas. Then I will have a consulting meeting with those experts, and finally I have a focus group. Then my team and I will, finally design a questionnaire. Then we have our pre-test. After pre-test, we go to the real survey. So it's a lot of work to do. think in the future I think we can talk here about holding the webinar first, because maybe every quarter or every 6 months we can have webinars. We set out a main theme, then we can have our joint webinar online. And I think our second plan is we sincerely want to invite the KREI people to come to Taipei, maybe for 2 weeks or even 1 month visit, and we can provide the free office for you, and you can go interview with any research fellow in our institution, and also if you want to visit some Taiwan research institute or university, we can introduce you to go. So I think because I'm also serving as the director of the Japan Center, in the last several months, we have 2 visiting scholars coming over to CRER, and they probably stay one month in Taipei. They find their place to stay, and CRER provide one office for them. And we also have several small seminars or brown bag seminars with the visiting scholars, and we exchange many thoughts between Taiwan and Japan. I think maybe KREI we can do the same thing, and because NTU the econ is very close to my institution, so we can all 3 parties can work together.
We will start we are planning to have right now it's NTU invites our staff, so they provide our plan is just to support I enjoy the international exchange program. I know about most of they have the good young scholars. And somehow I
Yes.
talk in the chat, and we have the joint magic scholars workshop with the NTU, CREI, and
Yeah.
so they're probably good somehow.
Yes, and originally I was inviting Dr. Chen, Jizhong Chen, to come over due to his visa problems, so he cannot make it here. But originally he wanted to present the Taiwan climate change adaptation policies. So maybe next time if we have a webinar, I can invite him to have a webinar presentation for you guys. Yeah. And he
He's a good scholar. He's a distinguished professor. Chongqing University. Chongqing University, top university, like Korea University. SMU is NTU. Korea University. Chongqing University. We are the better than NTU. So here's our publication much better than NTU. NTU has a whole NTU USA. But we have the 42 professor, we have the diverse faculty.
Yeah, so yeah, we will start a plan, and we hope in maybe next year. Uh, I think it becomes my duty because my president asked me, hey, what do you want to do? And so we will do the follow up. Yes, and hopefully in the future we have more activity with KREI. And definitely next time I will invite, not right now he's Professor Chen, uh, to to have a keynote speech online. Yeah, Professor Chen actually right now maybe he is the most famous person who was Dr. Macau's student. Yeah, yeah, maybe the most outstanding PhD student in Taiwan. Yeah.
So actually after the whole program, we prepared a happy hour outside the KREI lounge. So if you want to talk more with Dr. Lin or Professor McCarr, just feel free to join the happy hour. So our last presenter is Dr. Im Young-ah, and she's going to give us a speech about climate change in Korea.
Thank you. Yeah. I think I have just 6 minutes left. You know, the happy hour will start at 4 o'clock, and I don't want to make you unhappy at all. So I will do my presentation as fast as possible. Yeah. I hope that I can finish it. Yeah, in 5 or 6 minutes. Okay. Yeah. My name is Young-ah Lim, and from Korea Rural Economic Institute. I work for this institute here, and today I want to introduce the general picture of agricultural climate change adaptation policies in Korea. So this is a trend of greenhouse gas emissions from agriculture sector in Korea. So if you can see the enteric fermentation and manure treatment, because the number of livestock goes up and up, so the greenhouse gas emissions from this livestock sector goes also. But because the farmland declined over time, so the emissions from rice cultivation and agricultural soil has also declined. But regarding the methane and nitrous oxide, actually the agriculture is a very big source of emitting the pollutants. So that's why we have to think about how to do something, in agriculture sector to cope with climate change. So according to the Ministry of Environmental report, there's some impact of climate change on agriculture. But you can see the signs in this slide. So we have some positive and negative impacts. So for the adaptations, we want to decrease the negative impact as possible, but we also want to use these opportunities due to the climate change in the future. And also, from the same report, they analyzed the vulnerability of agriculture to climate change, but these size it's only based on the natural science studies. So actually, some socio-economic variables can be very important to analyze the vulnerability, but it's a kind of limitation of this report. And regarding the adaptation options, also it's based on the natural science only. So there's no economic evaluation about these adaptation alternatives in this report. So hope that in the future researchers, maybe our institute can contribute to evaluating these policies. And from the IPCC report AR6, the risk of climate change has already changed, because originally the risk consists of hazard, exposure, and vulnerability. But the future direction is like that. So from the IPCC, the researchers insist that the responses to the climate change has also affect the risk of climate change. So the concept of risk has more complicated right now. So regarding the risk in the context of response to climate change, so this is different from the original concept of risk from hazard, exposure, vulnerability framework. And also it can occur because of response to climate change fail to get the intended outcomes, especially maybe, for example, some failures to to dispute the low carbon technologies, or it can also occur because the responses cause adverse outcome, which is unexpected. And this risk should be potential, not certain adverse outcomes, because if it's certain, we can call it trade-offs between the benefits and adverse impacts. But this risk is a kind of possibility, so it is potential. And also, now we are studying the climate change adaptation strategies, which is funded by the Ministry of Agriculture in Korea. And also, we are thinking about some risk is a kind of a transition risk. So in the financial literature, they call the transition risk as a risk related to the transition to the net zero society. So I and my colleagues conclude that to think about this kind of risk together in our national adaptation strategies. So we try to define transition risk in agriculture, maybe reflecting the mitigation activities from the government. So this is just associated with the transition to the net zero society, which can potentially negatively affect the resilience of farmers, rural communities, and local and national governments. So this is a kind of presumably definitions we had. And based on the Framework Act on carbon neutrality and green growth for coping with climate crisis, every 5 years, our government has to establish the national adaptation strategies. So this is the main content of these strategies. And then now we are under the third version of this national plans. So also, because of the disasters last year, have you ever heard that POSCO was damaged by the flooding last year? So to cope with the disasters more effectively, now the third plan is under the revision. So, and maybe for example, there's a kind of new risk is added. So this is a kind of regarding the food security. So we think about the stability of supply and demand of imported agricultural livestock and food, because we are a big importer, not an exporter. And also these are the actions which are included in the national plan, and their action subjects are the Ministry of Agriculture and Rural Development Administration, one of the biggest research institute in Korea. And you can see the action listed here, but there are some limitations. So for the limitations of the current plan, one thing is that the risk is assessed only for the physical risks related to climate change. So we just suggest to think about more socio-economic variables to define the risk. And also we have to think about transition things, how the transitional efforts of the society can affect negatively on farmers or the stakeholders in the agricultural sector. And also, these actions are mostly on the focus on the R&D only. So these R&D tests of the research of the R&D tests should be distributed, and also it has to be linked to the real policies in the field or for the kind of national plans. So this linkage is very weak right now. So this is a kind of limitation also. And also, regarding the adaptation, we have to think about capacity building, especially maybe for the farmers. Although there are a lot of information of climate change and weather services, maybe like Taiwan, outside. But if the farmers cannot use the information properly, actually this is useless. So, but in the national plan, there's no action plan for the farmers or for interest groups to build their capacities about using or about interpreting this climate change information. And also, we wanna think about the mainstreaming the adaptations. The mainstream means maybe we can think about climate change aspects in every step of the policy making processes, but this is not this is not applicable right now, because if you look at the list of the action plans in the national plan, it's just kind of collection of the existing policies there's no new policies or there's no direct policies targeting the climate change adaptation. So we have to think maybe to change the framework of decision making in the policy making. So these are the concerns about next steps. Actually, I and my colleagues are thinking about it, and we also think about to maybe survey for the experts to get some advice of these ones. So we hope that maybe for the first national plan about adaptations, maybe we can reflect these factors more effectively there. Yeah, thank you.
So if you have any questions for Dr. Lim, just feel free to raise your hand.
Policy to old farmers. So, for example, average farm average age of the farmer is over 65. So my friend do not change the using the fertilizer and the pesticides. They put a lot of fertilizer and pesticide on his farm parcel. So how do you persuade? They don't understand at all about the climate change. They don't want to change the farming custom since he learned from long times ago.
Okay,
So
yeah.
the-
Yeah. Okay. Okay. First, based on the previous surveys, which is conducted by our team here, yeah, most of the farmers they recognize the existence of climate change. Also, most of them thought this climate change can negatively affect on their production. And regarding the adaptation, actually, it's a little bit different from the mitigation. Mitigation can be a regulating, to reduce the carbon emissions from their productions. But regarding the adaptations, actually, it can help them to increase their incomes or to stabilize their income sources. So actually, regarding the adaptation side, it's much easier for farmers to persuade. But as I mentioned before, if they are very aged, the other thing is they cannot use the smartphones or some, the information properly. So that's why maybe user-friendly education is really important, yeah, for adaptation in Korea. Well, we have to do that, right? Even if it's hard, yeah. Because adaptation is a little bit different from categorizing. Uh, as there are a lot of field researches in the local areas, yeah, like 도너검 기술원, and if they try to maybe persuade the people to use or not maybe some disaster-resistant breed varieties. It's also another case of adaptation, and yeah, it's very common things already outside there, right? Yeah. So yeah, right. We can think about subtropical fruits. They are grown in the southern area of Korea. Yeah. Hmm.
From 2018 to 2021, we had a 4-year project, and by that time we have four farmers association become our experimental site. So we trying to check out how to let those farmers, most of them are over 60s, how they can use the weather information to adjust or adapt the impact from weather or climate change. And I think the more efficient way is you need to reach out to the extension people. The people, they will have regular meeting with them almost every month. And if you can let all those extension people know how to use it, they will use their word, translate to them, and maybe sometimes teach to them. And if 2 or 3 people, they make a good use of weather information, and their performance, their revenue increase. Other farmers will follow. This is my experience.
So let's give a big round of applause for all 3 speakers today. So as I mentioned before, we prepared a happy hour outside in KREI Lounge, so we can do our discussion over there.